So you guys have this really big review for this really big final that's coming up. This really big worksheet goes through everything that's on the final and then some. So before you turn it in, these next few videos are going to go over everything that's on it, give you the answers, as long as you watch the video, and go through the topics one more time too. So we're going to do Unit 1 and Unit 2 in this video decently quickly, and see where we go from there. Your next video will be Unit 3, and then I believe it's periodicity in Unit 4. After that's what I've got planned. I'm trying to crank through all of these and get you ready. The first thing we're looking at here is your practice on branches of chemistry. Here are my hints. For analytic, you're looking for test or how much. Biochem, you're looking for some critter name and a reaction. Inorganic, you're looking for a metal. Organic is carbon. Carbon's big. Physical, temperature, or reaction rate. Those are the Q words for physical. So bacteria, there's your critter. Glow in the dark, biochem. A carbon, organic is your second one. Warming, T, that changes physical. So physical chemistry. Nickel, metallic, inorganic. And a sample of iron ore is what? It's tested, analytic. This next thing is probably some of your least favorite things in here. There's one question on it, but so many of you are uncomfortable with significant digits, I'm going over it again. If it's not 0, it is significant. That one's got 3. If you've got zeros after your decimal and after a number, they're there for a reason. 1, 2, 3, 4, 5. That one's got 5 significant digits. If you've got zeros at the beginning and no number, cross them out and just start with your number. 2 significant digits there, and that's 0 after a number, so we keep it. Those all are, by the field goal rule, you've got zeros between the 3 and the 1. For 300, there's no decimal, so only the 3 is. Why? We could write it as 3 times 10 to the second, which makes those not significant. 50.0, we took the time to put the points, so 3. This is a different example. We haven't done any like this with the exponents. We don't even look at that. 1, 2. 2 significant digits. This one's like this one. Draw your line over till you get one. Only 1 significant digit there. This decimal makes that 0 significant, along with the 1 and the 5, so 3. And for this one, they all are. We've got an experiment here with a science class. We were running a reaction at 20 degrees Celsius and changing the temperature, making it physical chemistry, because it's the temperature that changes. The independent variable, what is changed by the researcher, is temperature, and what changes as a result is how fast the reaction happens, so reaction speed. For your steps of the scientific method, I got you guys on that on the test. Form your hypothesis first? No. Do not form your hypothesis first. Everyone was telling me that. I'm going to form a hypothesis. How? Make observations is first. Form your hypothesis second. Test your hypothesis next. Decide if it's right or wrong. So you're looking there at making sure you know that your testing of hypothesis is not first. You have to make observations before that. Mendeleev modern periodic table 1869. As long as you know 1800s, you're good to go. Chart of all known elements. Group making up the majority are your metals. Your poor conductors of heat and electricity are nonmetals. Shiny metals. Properties in between are metalloids. Many gases are nonmetals. And the metalloids divide. Big thing to know is that the majority of the elements are metals. Malleable can be pounded into a flat sheet. Ductile can be pulled into wire. Tensile strength, ability to resist breaking, those are properties of metals. You're looking for metals that have those properties. Looking horizontal and vertical here. Horizontal, vertical. Group is vertical. Family's another word for group. It's vertical. Periods run across, horizontal. Column, I learned that in history class. Columns are vertical. Rows are the whole row across, horizontal, and a series is a portion of a row across, like the lanthanides and actinides. You should have these group numbers written on your periodic table or memorized by now. Alkali metals are group 1. Alkaline earth, Group 2, halogens 17, noble gases 18, transition metals 3 through 12. Listing your actinides, I just go straight for the good ones. Uranium, neptunium, plutonium. Lanthanides are not as exciting. It's like europium and samarium and neodymium. They're just not as exciting name-wise. We got the formula mass, and I did this before. I skipped the density on the way through. So what I'm going to do is just erase this top part, go back to your previous page for the density calculation. I think I kind of had it tucked up in there and really just missed it. So I'll do your density calculation and then your formula masses. And I believe once we get to the formula masses, we good to go. Oh, empirical and molecular formula too. Wow, there's a lot on here. Density is mass over volume. It's been mass over volume. You do 195 divided by 8.5. That's going to be grams over milliliters. Units on density, grams per milliliter. That's awesome. 195 divided by 8.5 gives me 22.94. I can only keep two significant digits, 23 grams per milliliter. For C4, that means 4 carbons, and 10 hydrogens. It's a compound called butane. So what I want to do, since it's 4 carbons, is 4 times its mass from the periodic table, and 10 times hydrogen's mass from the periodic table. I got 48.044 there, and 10.079 here. So 48.044 plus 10.079 gives me a mass of 58.123 grams for butane. That was my first one I needed a mass of, and I'm hurrying because I got a 15-minute video limit. So for magnesium nitrate, 1 magnesium, those parentheses say 2 nitrogen and 6 oxygen. 24.305, just 1 magnesium. 2 times 14.007 for nitrogen, and 6 times 15.999 for oxygen. 24.305 plus 28.014 plus 90 something, 90, let's do 6 times 15.999 there. I think it's 93.994. I get 148.313, and that looks pretty good for that. And it would be in grams. So empirical formula, moving right along, empirical formula is reduced to the lowest ratio of subscripts. Molecular is an actual formula, so if you check out the bottom, C7H16 can't be reduced, empirical. NaNO3 can't be reduced, empirical. MgCl2 can't be reduced, empirical. Ha! C2H4 can. This is a molecular formula. Reduces to CH2. C4H8O2, let's reduce that also. So molecular C2H4O and ALPO, ALPO4, already reduced. Empirical. There you go.